Throughout the universe, there are forces fundamental to how things move. Just as gravity is key to how things move on Earth, a process called magnetic reconnection is key to how charged particles speed through space. The more we understand how those particles are accelerated, the better we can protect our spacecraft and astronauts as we explore deeper into the solar system. And now, NASA's Magnetospheric Multiscale Spacecraft, or MMS, has discovered magnetic reconnection occurring in a new and surprising way near Earth. Typically, images of our planet from space show a blue-green sphere engulfed by the darkness of space. But invisible to the eye, a vast network of magnetic energy and particles surround our planet. Earth's magnetic field creates a protective bubble that shields us from highly energetic particles that stream in both from the sun and interstellar space. As the solar wind bathes our planet, Earth's magnetic field lines absorbs this energy and gets stretched. And like elastic bands, they eventually release energy by snapping. As a result, particles in the region are flying at supersonic speeds. That burst of energy is magnetic reconnection. It's pervasive in the universe. It happens on the sun, around Earth, and flings particles across the solar system. Scientists have observed this phenomenon many times in the magnetosphere, Earth's vast magnetic environment. Now, in a new study, MMS caught the process occurring in a new region. For the first time, magnetic reconnection was detected in the turbulent magnetosheath, the boundary between the magnetosphere and solar wind. This region is made up of turbulent plasma. It's one of the most chaotic regions in the near-Earth space. MMS captured 3D observations by flying 4 identical spacecraft in a tight pyramid formation through the magnetosheath. These arrows show the hundreds of observations MMS took to measure the changes in particles and the magnetic field. This is the moment MMS sees bursts of energy from magnetic reconnection. But these signatures don't look like standard reconnection. Compared to standard reconnection that occurs over tens of thousands of miles, this new magnetic reconnection spans only a couple of miles within turbulent plasma. These reactions are essentially much smaller but more stretchy elastic bands that accelerate particles 40 times faster. In short, MMS spotted a completely new magnetic mechanism that's much quicker than we've seen before. Just like when you mix milk into coffee, turbulent plasma in space moves randomly and creates vortices. It can transport particles and energy, but a lot is unknown about how these particles move through these regions. Showing that this new magnetic reconnection plays a role in turbulent plasma gives scientists insights into how turbulence influences particles moving through space. By looking at such fundamental processes in space at both large and small scales, scientists can learn what drives the complex environments we travel through to explore our solar system and beyond.